Carbon compounds are present everywhere, that is, food that we eat, clothes that we wear, and even in the lead of the pencil by which we write. It is the 17th most abundant element found on the earth. It is found in free state as well as in the combined state. You can find it available as coal, graphite in elemental state, that is purely carbon form, whereas it is present as metal carbonates also. And you can also see it with the other elements, that is carbon dioxide gas in combined state, that is in combination with oxygen. So here I have listed some places wherein you can see the presence of carbon, and here is the list given below that illustrates the importance of carbon compounds in our daily life. So first one is foods, second one fuels, households and commercial articles, textile fabrics, drugs and disinfectants, poisons, perfumes, explosive dyes, war gases. So these are different items wherein we can see the presence of carbon. Okay, so we see that carbon compounds are some by some or the other means they are useful in our daily lives. The atomic number of carbon is 6. So if you look at this image, there is nucleus and electrons revolving. सो आता ऑलरेडी तुमका खबर आसतले जितले इलेक्ट्रॉन्स आसता तितले equal number of protons आसतले inside the nucleus. So in this, since the atomic number is 6, there will be 2 electrons in K shell and 4 electron, the remaining 4 electrons in L shell. Now whenever an element or an atom exists, it will always try to attain a noble gas configuration. By this I mean that if समज एकूच shell आशिल्लो, that is K shell, जाल्यार it should compulsorily have 2 electrons inside it. आता समज हांगा अनेक shell आसा, as in the case of carbon atom, that is L shell आसा हांगा दुसरो shell. So तितून maximum, or it is compulsory to have 8 electrons in the outer shell or valence shell. Other, since there are 4 electrons in the outer shell, the valency of carbon is 4. Ata, there are two possibilities to attain noble gas configuration. Either it will try to lose these 4 electrons so that only 2 electrons remain in the K shell, or it will try to gain 4 electron from other atom. So after gaining 4 electron from other atom, it will have total 8 electrons and hence it can attain noble gas configuration. आता हे जे carbon asa, it is a special case wherein it is not so easy to just lose or gain those 4 electrons. जाता कितें, if समज 4 electrons extra घेतले from other atoms, so there will be already existing 6 electron plus extra 4 electrons means 10 electrons असा. आणि already 6 protons are there inside. हे जे number असा ते आता equal ना, 6 protons आणि 10 electrons. So dominating कोण हांगा negative charges, that is electron. So now the carbon atom is unstable with negative charge. This possibility is ruled out because gaining 4 electron would also mean that it will be difficult for the nucleus to hold these extra 4 electron. So तेका लागून म्हणटा की proton, number of proton आणि electron सदा equal असपाक जाय. To lose 4 electron, again समज हे 4 electron आसा ते lose केले to other atom, जाल्यार की जातले, total number of electrons will be 2 आणि already 6 protons आसा भितर. So again हांगा खंयचो charge dominate जाता, protons with positive charge. So the carbon atom will have positive charge and that is in turn unstable. So both the cases we see that carbon atom is unstable, and to lose 4 electrons also it will require large amount of energy. Both the cases are ruled out for carbon. Hence, the only option that remains for the carbon to attain noble gas configuration is by sharing its valence electrons with other atoms. Means gain सुद्धा करपाना, lose सुद्धा करपाना. It will just share its outer electrons with other atom, and this sharing is called as covalency, and the bond that is formed between the outer electron of carbon with the outer electron of the other atom is called as covalent bond. So bond formed by sharing of an electron pair. Pair means two electron, one of carbon, one of the other atom. Between the two atoms, that is called as covalent bond. Now these are two properties of covalently bonded molecules. If you compare ionic compounds means तिथून cation आणि anion असतले, that is positively charged atom, negatively charged atom, like HCl, H plus Cl minus. So if you compare such ionic compounds with such kind of covalently bonded molecules or compounds, these molecules will have low melting point and low boiling point because the bonds are very weak. And also these molecules will be having poor conduction, that is they are generally poor conductor of electricity since there are no charged particles. Charged particles is only possible when they lose or gain some electrons. Now here there is sharing of electron, that's why there are no charges formed and hence they are poor conductor of electricity. When I mean by sharing of electrons, both atoms need to contribute for bond formation. Now, before going ahead with covalent bond in carbon, let's have a look at covalent bond in other elements. Atoms of other elements like hydrogen, oxygen, nitrogen, chlorine, and few more elements also, they show sharing of valence electron. Okay, so let's have a look at formation of hydrogen, oxygen, and nitrogen gases. First, we'll start with hydrogen gas. Now we already know the atomic number of hydrogen is 1. Okay, so there will be one electron. So it means that there is only one shell. And we have already seen in the previous slide that if there is only one shell, to attain noble gas configuration, there has to be two electrons. In this case that is present over here, you see only one electron. So ह्याका एक extra electrons आहे to attain noble gas configuration. There has to be two now. So that extra electron, okay, the need of extra electron is being satisfied by one more hydrogen atom. So एक असोच hydrogen atom, just imagine that there is one more hydrogen atom is present over here with one electron in its outer shell. Okay, just a duplicate of this. आता किती करता हो आपलो इलेक्ट्रॉन असा तो तेका तेजे कडेन शेअर करता आणि even that next hydrogen atom is sharing its electron to this one. So both are mutually sharing its electron to each other, and hence this particular hydrogen atom will have two electron, one from its own, other from the other hydrogen atom. Similarly, the next hydrogen atom will have one of its own and the other which is already shared by the other atom, and like this way both are attaining noble gas configuration. Okay, so this is covalent bond because they are sharing the electrons. Here, since one pair of electron is shared between hydrogen and hydrogen atom, I denote it by single dashed line. So if there is single dashed line between the atoms, it means that there is sharing of one pair of electron, one from this atom, the other from other atom. And this type of covalent bond is called as single bond. So whenever you encounter hydrogen atom, see that you always put single bond for it. The next case is that of oxygen atom. So the atomic number of oxygen is 8, that is 2 electrons in K shell, 6 electrons in L shell. So here there is one more shell. So in the second shell, basically noble gas configuration tells you that for L shell there has to be total 8 electron. आता आठातले फक्त 6 electrons are present. हेका आणि दोन extra electrons are to complete noble gas configuration. So what it will try to do is it will share its two electron
with the other oxygen atom, same oxygen atom is present. Okay, just imagine that one more oxygen atom is there with the same configuration. So हो आपलो 2 इलेक्ट्रॉन तेका दिता, तो आपले 2 इलेक्ट्रॉन out of 6 outer electron हेका दिता. So two electron from each oxygen atom are being shared with each other. So you see that there are two electron pairs that are being shared. So दोन तेजे कडल्यान घेऊन हो आपलो octet or noble gas configuration complete करता. Even that other oxygen atom दोन हाजे कडल्यान घेऊन आपलो noble gas configuration complete करता. So since there is sharing of two pairs of electrons, I denote it here by two dashed line. Two dashed line means two pair of electrons. Two from here, two from here. So hence this type of covalent bond is called as double bond. When it comes to nitrogen, atomic number is 7, 2 in K shell, 5 in outer shell. So it needs 3 more electrons to complete noble gas configuration. So similar like hydrogen, oxygen, same theory. 3 इलेक्ट्रॉन हेका जाय, सो आपलो 3 तो दुसरे नायट्रोजन ॲटमाकडे शेअर करतलो, बिकॉज इवन द अदर नायट्रोजन ॲटम विल नीड 3 इलेक्ट्रॉन. इवन तेजे कडेन 5 इलेक्ट्रॉन आसा, तेका 3 जाय. सो हो आपलो 3 तेजे कडेन शेअर करता. इन टर्न दुसरो नायट्रोजन ॲटम आपलो 3 इलेक्ट्रॉन हेजे कडेन शेअर करता. सो बोथ आर म्युच्युअली शेअरिंग 3 इलेक्ट्रॉन with each other. So hence there is three dashed lines, that is three pair of electron is being shared with each other, and hence this type of covalent bond is called as triple bond. So coming back to covalent bond in carbon, let's take the case of carbon dioxide. आम्ही already पहिला की valency of carbon is 4, so there are 4 electrons and it needs 4 more electrons to complete noble gas configuration. Oxygenac 2 electrons are to complete its noble gas configuration. We have already seen over here, and even this the same oxygen. So it will try to bond with double bond. So आता out of 4 electron, okay, of carbon, oxygenac 2 जाय. So 2 electron ते कार्बनाचे घेता, okay, by sharing. So carbon आपले 2 electron ह्याच्याकडे share करता. 6 already present असा oxygenaकडे. So 2 2 electrons of carbon, so असे करून 8 जाता oxygenaकडे total. Even this oxygen the same way, 6 is already present over here. 2 out of that 4 is being shared from carbon. So carbon आपल्याला 2 हेका दिता sharing by sharing, आणि उरिल्ले 2 ते ह्याच्याकडे share करता. So in this way oxygen, both oxygen atoms are getting 2 electrons each from carbon and attaining noble gas configuration. In the same way, हेका extra charge आशिले 2 ऑक्सिजनाकडल्यान घेता, 2 या ऑक्सिजनाकडल्यान घेता. In turn, carbon आपले noble gas configuration attain करता. So in this way, by sharing each other's electron, there is formation of carbon dioxide by covalency. If you look at methane, again valency 4, so 4 electron already present asa, okay, 4 जाय. So even for hydrogen atom एक एक जाय. So this hydrogen atom will take or share one electron from here. Hydrogen atom will share one electron here. This over here, third electron and fourth electron over here. So like this way, 4 electron जे कार्बनाक जाय ते ह्यांचे कडल्यान शेअर केल्ले मेळटा. सो हेजे कडे जाता 8 इलेक्ट्रॉन, आणि इन टर्न हायड्रोजनाक इच हायड्रोजन ॲटमाक किती जाय, एक एकूच इलेक्ट्रॉन जाय. सो हो एक इलेक्ट्रॉन हेजे कडल्यान शेअर करून घेता. अशें करून सगळे हायड्रोजन ॲटमा कडेन 2 इलेक्ट्रॉन आसतले. So similar like this. So since there is presence of hydrogen atom, there is single bond. Here in this case, since there is oxygen over here, you show it by double bond because there is sharing of two pairs of electron.